Okay, today we're going to start looking at exponential growth and decay, and we're going to primarily focus on exponential growth. So if you will please fill out your essential question and get your notes set up and start the video when you are ready. Okay, so talking about exponential growth. We already talked about what an exponential graph looks like. If we are talking about exponential growth, then we should have a graph that shows it is growing. Okay, so an exponential growth graph is going to look at something like that. Here is our formula. This is what our formula for exponential growth will look like and how we will, what we will use to generate an equation. The y value is always the final amount of something. The a value is always the starting amount, what we begin with. Okay. You know, when we talked about our initial growth and decay, this was our b value, and now it's represented with 1 plus r, or another name for it is the growth factor. The growth factor. The r stands for the rate or percent. And we're always, when we put this into our equation, we're always going to put it in decimal form. And then the t is going to stand for our time. Now you may be wondering, what does that 1 represent? 1 represents that 100% of what we're starting with. We have an amount of something, and then we're increasing it by a certain percent or a certain rate, and so we add it on. And that allows us to be able to calculate the final amount. If you will look at the word problem sheet that you also picked up, I want to look at this first word problem. Okay. Read it to yourself for a second. And I want us to write the equation for it. So we don't know what the final amount is right now. We know that our beginning amount, A, is 584 times 1 plus, and the percentage or rate was 6.5%. So in a decimal, that would be 0.065 to the t power. Okay. You could also write that as simply y equals 584 times 1.065 to the t power. Okay, so either way you can see it. So there's our equation. Now it says predict the average annual cost for 2015. Well, we need to know how many years that is. So 2015 from year 1985 is 30 years. So we're just looking for y when t has a value of 30. So nice and easy. So all we have to do is take this, plug in t, 30 for t, and type it into our calculator. Remember to get exponents higher than 2. We use that little caret key that's next to the x squared key. That's one way. There's several other ways, and you can get that. So what we find out is, what is the average cost? It is about $3,862.79. Make sure that you can type that in your calculator and get that as your correct answer. Okay? Okay, let's go back to our foldable and let's look at compound interest. Compound interest, remember, is when the money is growing and it's growing faster. It's interest that is earned not only on the principal but on the interest as well. Okay, it's going to be a little bit more complicated than what maybe you've done in the past. So still, the Y value still stands for the final amount. How much total you have, how much total you need to pay. P is still the starting amount, or it has a fancy name called the principal, what we start with. R is the rate still. Okay. The N is the number of times that our money is compounded. And we're going to talk about that more in just a second. And then T is still the time. Okay, so what it compounded means is how many times are we going to calculate the interest. So compounded quarterly, that would mean the N value is 4. We're going to calculate it 4 times. If we compound it monthly, that means we're calculating it every month. Well, there are 12 months in a year. If it's compounded semi-annually, that means twice a year. Okay? And so again, we're just going to look at some problems and fill in the numbers to the formula and do some calculating. Okay, so let's go back to those practice problems. Okay. So looking at this first example, it says find the balance, that's our Y, in an account if 4,000 was invested, that's our P, earning 6% interest compounded annually after 5 years. Okay, so we're going to say Y equals, our starting amount is 4,000 times 1 plus our rate is 6%, so we're going to put 0.06. Now this time is only compounded annually, but I want us to make sure that we see that step of dividing. Okay, and then to the N times T, so 1 times 5. So that's what it would look like. That's how we're going to input it in our calculator. If we want to simplify it a little bit to make it easier when we put it in our calculator, that's what it's going to look like. Okay, type this in. Make sure that you can get $5,352.90. Okay, and the last problem. You might want to pause it a minute, see if you can fill in the formula yourself first, and then turn it back on, and see if you did it correctly. So our beginning balance was $500 times 1 plus my R is 4%, 0.04. Now this time it's compounded quarterly. So we're going to divide by 4 to the 4 times 6. So this is what it would look like. Okay. Again, we're finding the balance. When you type this in, when you calculate it, you should get $634.87.